Yes, am I audible to all of you?
Yes, ma'am.
Yes, Alia, sure, let me know it. So we had started with the kinematics of circular motion, derivations we did, and all the three equations you already are aware of. Let us just discuss these equations, because see, you already know that these equations are exactly based upon the motion in a straight line equations, right? So this says that on application of a constant torque, a wheel is turned from rest through 400 radian in 10 seconds, right? Find angular acceleration and angular velocity after 20 seconds. First part, angular acceleration. See, theta is equal to omega naught t plus half alpha t square. So see, initially it is saying from rest, so this becomes 0 because I have to find out angular acceleration. And this is given 400 radian, that is theta is given 400 radian, this is theta. And time is 10 seconds. So the only appropriate equation that was left to use was this. So 400 is equal to torque, we'll do torque. Just forget torque right now. Torque is the next topic after this question. So it's just it's force. It's right now, just remember in this question, force, a constant force is being applied. We'll do it. The next section is torque. So 400, this is half alpha t square is 20 into 20. So this cancels off. This becomes 400, right? 20 into 20, correct? So this becomes these both and these both, they get cancelled. So alpha becomes 2 radian per second square. Nextly, we have angular velocity in the same question. See, omega is omega naught plus alpha t for u, similar to equation v is equal to u plus at. Keep these in mind, then these will be very easy to write. I also remember in this manner only always. So what is omega? Yes, we have to find this. Initial velocity is again 0 alpha. We have calculated this is 2 into 20. So omega is 40 radian per second. All right, this is 2. Note it down quickly. One more question we'll discuss before starting with torque. Yes, Ali, I've received them. I've just checked it. I've received the questions. I'll discuss it. See, class, before starting with the next question, no, you have to have a knowledge about little conversions. Okay. When we say one rotation is this. This is one rotation. When the body completely rotates. So that is 2 pi radian. All right, one rotation you can say, or even one revolution you can say. Even if the body completes one revolution, rotation is turning on its point, like the earth rotates on its axis. So earth also makes complete that is 360-degree, right? When the earth rotates from the starting point to the end, that is from day to night, earth completes 360 degrees. And when revolution also occurs, that also total subtends angle 2 pi. So one rotation, one revolution, this is 2 pi radian. Now, angular velocity, when we talk about one, that becomes revolution or one rotation per minute. One RPM will be given to you in a lot of questions. So this means this is one revolution per minute. Fine. So how do we calculate it? Revolution means the distance that is taken, angular displacement that is covered revolution. Minute is the time taken. RPM is given a lot. Sometimes RPS will also be given. That is revolution per second. So that is not a very difficult thing to solve, because if it is given already in seconds, when it is given in minutes, then it becomes a little difficult to catch up. So omega is revolution per minute. So how much revolutions are being covered, right? What is the number of revolutions? That you have to find out divided by the time. So mainly one conversion we have that is helpful for you. Remember 1 RPM, this is equal to pi by 30 radian per second. This will be helpful to you in most of the questions. I'll show you the next question. This is that the angular speed of a motor wheel increases from 1200 RPM to 3120 RPM in 16 seconds. Means angular speed increases from this to this. So initial value is this 1200, final value is 3120, right? So omega naught and omega. This is how you have to identify all the variables also. That is also one of the tasks which you have to follow, right? So 1200 RPM to 3020 RPM in 16 seconds. So time is 16 seconds. We have to find out acceleration. So here the problem that arises is that we have to convert it. Either write pi by 30 or you can write it as 2 pi by 60 also. This is actually 2 pi by 60. See, revolution is what? One revolution. This is 2 pi. What is 1 minute? This is 2 pi radian and 1 minute is 60 seconds. So that makes it 2 pi by 60 radian per second, which is further written as pi by 30. All right. So yes, it is asking angular acceleration in the first part. See, omega naught was given as 1200 RPM. So that becomes 1200 into 2 pi divided by 60, 2 pi by 60 or pi by 30. So this becomes 40 pi radian per second. Initial velocity. Coming to final velocity. This is 3120 RPM. So just 3120 multiplied by pi by 30 or 2 pi by 60. Both are the same thing in any case. 0 will be cancelled. 104. 104 pi radian per second. Initial velocity we have, final velocity we have, time we know it's 16 seconds. Now we just have to find out what? Angular acceleration. So omega is omega naught plus alpha t. Omega is 104 pi. Right. And initial was what? We calculated, no? 40. 40 pi. Plus alpha is unknown. This is 16. Now coming back to your normal equations, this you can solve, right? 104, 46, then 4. So 64. 64 pi divided by 16. This you can further solve it. 16 by 64. So this answer will become 4 pi radian per second. You ultimately have to give your answer in radian per second square. That's why you have to perform the conversion. And yes, class, this is an important part. How many revolutions does the wheel make during this time? How many revolutions does the wheel make during this time? See, what is the number of radians? What is the angular displacement that is coming here? Theta is equal to omega naught t plus half alpha t square. Okay, class. Theta will be 40 pi. Time was 16 plus half. Acceleration was 4 pi and time was 16 square. So 2, this will cancel. This will be cancelled. 256. From here we have 4. So 4 and 2 plus 2, that will be 2. Then 1 will go, 4 plus 1, 5. 1. Please check this. I've just calculated it orally, so it can happen that some errors are there. While writing, no, please just cross check. Don't just copy it down because I've done it randomly. Orally, I've done it. So 1552 pi radian is the. Now this is what this is radian. This is radian. What do we have to find out? Do we have to find angular displacement? No. We know that 1 revolution is equal to 2 pi radian. What do we know? We know 1 revolution is equal to 2 pi radian. Let me write it other way around. Two pi radian is equal to 1 revolution, right? So what is 1 radian equal to? Apply your unitary methods. What is 1 radian equal to? One radian is equal to 1 by 2 pi revolutions. So what is the number of revolutions for 1052? 1152. For 1152 radians, just multiply it. So 1152. Pi was also here, no? Pi. Pi divided by 2 pi. So pi will be cancelled. Number of revolutions become 576 revolutions. Clear? We had to find out the number of revolutions. Number of revolutions we had to find out. So if we know that 1 revolution is equal to 2 pi radian. So 1 radian is 1 by 2 pi. So this much radian will be multiplied. We'll get the number of revolutions. So this concept, you will find it in lots of books. So make it a note point. Write it down. And any doubts you have, let me know. Now we'll start with torque. Torque, no, that came in the previous question. The word torque came. Torque we'll do now. Okay, class. Now the next topic, torque. So that completes with the circular motion kinetics. Coming to torque, see, torque was used in one of the questions also. Torque is basically the rotational analog of force. The way we have displacement. So in rotation, that displacement becomes angular displacement, the theta that is covered, right? You have linear velocity. So whenever something rotates, now the velocity that is generated, that we call as angular velocity, and rate of change of angular velocity gives you angular acceleration. Similarly, whatever forces are acting when the body is translating, that is known as translation force. Normal linear force we call, which we denoted by the symbol F, right? Then we have when a body is rotating, when the body is in rotation, now the force that will occur. When the body is in rotation, now the force that will occur, that we no more call it as force, we call it as torque. All right, because see, when a body was moving, just force acted, right, on the body. But when there is an axis, suppose, let me give you an example, fan. So take the example of fan. There is an axis, then there are three blades which are attached, right? This axis is fixed and rotation is occurring at the tips of these axes. Yes. So now the force that occurs is known as torque. This force that occurs is known as torque. And this separation has to be perpendicular. That's how fans are constructed. Suppose this entire fan starts moving forward, that will not be called as torque. Though we know fans do not move, the ceiling's fan will never move straight. It's just an example I'm giving. Suppose the entire fan starts moving forward. Now the force generated, that will be called as a linear force only because the fan is moving forward. But the forces which are generated here at the tips of the fan, that is known as torque. So rotational analog of force is known as torque, means whatever force is occurring when the body is in rotation. That is what is meant by torque. And formula of torque is very, very simple. So yes, moment of force about the axis of rotation is called torque. You have to have the axis of rotation. R is position vector. See, axis of rotation you people have to have in your circular motion. When we did questions on from based on center of mass, that time also you have to choose an axis. That axis can be passing through the origin center of line. All right. So R is the position vector, theta is the angle between force and radius. Now look at this figure. This is the origin. So I have taken this as the axis, right? So that's why this is the origin. This is the point P on which I want to calculate the torque. Let's say some force is occurring, F force is occurring. Now the separation from this point to this is R. Whenever we calculate torque, the force that is occurring, linear force is occurring, that is 1 F. One more, you have the separation as R. We always calculate the perpendicular separation. See, if I take this, is this perpendicular to this point too? No, it's exactly parallel. So what did I do? I extended this and I have drawn a perpendicular, R perpendicular on it. This separation is R perpendicular. This is the force occurring and the torque that will be generated. I'll show you. See, the derivation is very easy. This is actually for the derivation purpose. You will notice yourself, you don't calculate it like this. This construction part is for the derivation purpose. See, suppose the example that I was giving you for the fan one. 3 blades are there. This is the axis, right? So this separation from, suppose this blade is present. So from this blade, edge of this blade, right? The blades move. So edge of this blade to the axis, this is the rod which is connected to the ceiling, right? This separation is R perpendicular. So because this is the axis, this actually happens. Force occurs like this, R perpendicular is there, you get your torque. So this is just for construction, your derivation purpose. Derivation is very easy. It comes in 2 markers only, not very lengthy questions. This angle I have taken as theta. So because the vertically opposite angle, this will also be theta. Now, if you take this, what is this triangle? ONP. So in triangle ONP, what exactly is sine theta? Perpendicular by hypotenuse. So that becomes ON divided by OP. That is R perpendicular divided by R. This is a normal R vector. This is the perpendicular component that I have extracted. So what is R perpendicular? R perpendicular is R sine theta, right? So what is exactly torque? Torque is RF sine theta. RF sine theta. So RF sine theta, remember when we did vectors, that time we discussed dot cross product. So two vectors, if they are getting sine theta, it means we are getting the third quantity by cross product. So R perpendicular, not R perpendicular cross F, R cross F. Vectors, cross product of two vectors is a vector quantity. So torque is also a vector quantity. And remember, it is R cross F, not F cross R. Remember, when we did cross product, we discussed that this is anti-commutative. You cannot interchange. A cross B is not equal to B cross. And if you have to write R perpendicular, so that is directly, then no need to put sine theta because that will involve sine theta. You'll already solve it like this. So what is R perpendicular? R perpendicular, this is the perpendicular distance between axis of rotation. This is the axis of rotation and line of action of force. The line of action of force. So torque is equal to R cross F. SI unit, force and radius. Force Newton meter. Direction is given by right hand thumb rule. See, you don't need to worry about right hand thumb rule right now. It's just that towards you will be able to, we'll do it in a trick that will help us so that we don't need to apply any hand rules. Anti-clockwise and clockwise we'll try. It's an axial vector actually. So the direction is given through the along the axis that I'll discuss. Anyways, one more point before we start with momentum. See class, suppose this is a rod that is given. Let's take an example. If I am saying no, the axis is present over here. Suppose I'm saying the axis is present over here. This is the axis. All right. Some force is acting. Let's say some force F1 is acting. Some force F2 is acting. Right? Some force F1 is acting. Let's say from this point, some force F2 is acting. This separation is R1. Now see, when we are calculating the first torque, when we are calculating this one, F1 and R1, see torque is equal to R1, F1 sine theta. They both are perpendicular to each other, force and R1. So theta is 90 degrees. So your torque becomes R1, F1. But coming to the second case, in the same case, this is R1, this is F2. What I'm trying to tell you is that you choose the angle between these two. Torque will still be R1, F2 sine theta. But now your theta is 0 degree. Both are parallel, right? 0 degree or 180 degree also. 180 degree also you can see. Because this is not clear in this example which I've taken. So in any way, torque will be 0. So it cannot be parallel. Okay? Angular momentum I'll discuss. All these things will come together. But before that, just note down this, make a heading torque, start writing about it.
What will be the SI unit?
Yes, someone is asking something, Harsha.
Ma'am, what will be the SI unit?
SI unit is Newton meter.
Okay.
Yes, Harsha. Dot product is commutative. If you are writing, suppose work done is F dot S. So you can write it as S dot F also. Answer will be the same in both the case. But see, remember we did determinant system. So when we do R cross F in the determinant I cap, J cap, K cap, we write first the initials of R, then F. So if you reverse it, entire answer will be different. All right. Now coming angular momentum. See, linear momentum we discussed in laws of motion. Linear momentum was what? It was the product of, remember, what was the formula of linear momentum? Anyone? Yes, correct, Harsha. Mass into velocity. Others also? Yes, Alia, very good. Mass into velocity. That was linear momentum we discussed. So linear momentum was basically the product of mass and velocity. Now, the way we have no torque is what? Torque was linear force that was multiplied to the radius. Yes. Similarly, here also angular momentum. Linear momentum was different. Angular momentum will be R cross P. That is L is equal to RP sine theta. And R perpendicular is the same, R sine theta. Fine. So angular momentum, you can write it as same. So figure will also be the same. This I don't think so. I need to explain this is the momentum this time instead of force. So it's an axial vector directional along the axis of rotation. It means suppose the axis of rotation is this. Momentum is occurring here. So it will be pointing towards it, either clockwise or anti-clockwise. This is how we give. So this anyways, it will be clear through the question. Let's start with inertia, then only you'll be able to understand. And note it down, then I'll start with inertia. First note it down. Now C class regarding moment of inertia. You don't have any derivation for moment of inertia. Just remember the form. One basic simple formula you have. See, if something is present, let's say this is a mass present and the axis of rotation is this. This separation is R. Then you have another mass M. This part is easy also, difficult also. Some questions are there that are difficult also. Some questions are there that are very easy. So please be careful with moment of inertia. Every question is not trivial. So see, this is M2 R2. So moment of inertia, this becomes M1 R1 square. Moment of inertia becomes M2 R2 square. So what is the total moment of inertia? M1 R1 square plus M2 R2 square up till Mn Rn square. So, and if you want, what you can do, you can write the integral also, total integral of dmr square if it is variable. It's like you are adding all these, no? Integration is cumulative adding. See, calculate moment of inertia of a ring about an axis perpendicular to the plane passing through its center. Though this I'll tell you in detail, you have so many figures. This is a disk. I've kept it in XZ plane. This is the axis of rotation, right? Passing through its center, perpendicular to the plane and passing through its center. Suppose let's say the radius is R and mass of the disk is M. So moment of inertia is represented by I. So you know its SI unit also. SI unit will be what? kg meter square. Mass it's kg, distance it's meters. So kg meter square is only used. So moment of inertia will become mr. That's it, how we write it. Okay, now we'll discuss this in detail. Let me tell you this also, how to use this. I'll tell you this through the help of question only. Integration we involve. Note it down, and for different figures, we have so many moment of inertia which you have to remember. Disk, ring, cylinder, circle, all these you have to remember. This was in the form of question, but by the end of this lesson, you should be able to remember this as it is. Start noting it down. Masses suspend. No. Masses are not suspended. This I'm just telling you that if mass is there, like in this example, disk was present. So mass is present, one axis is there. This I'm just telling if even if the masses are separated from the axis, we'll consider it as R. This is not a suspension or something else. This is just a random figure that I've drawn. This question says calculate moment of inertia of a rod. See, don't take these questions as separate questions that we are doing. This is what you have to remember. In the form of, initially I have done it in the form of question. After this question, we will do it directly for circular ring, for disk. Okay. So don't think that this is just a question. So this is a way how to solve it. Initially, if I just tell you the formulas, it will be difficult for you to understand. And sometimes the length of rod part is asked. See, how will we solve this? Just understand. Please pay attention class right now. Because the rest of the I have shown you also. Then you just have to learn up the formulas. This is an axis I have taken in the middle. Suppose the length of the rod was L. So now this becomes L by 2, this becomes L by 2, and rod is rotating here. This is the axis of rotation. Means the rod is rotating here like this. This part is going here, this part is coming here, this is going here like this. Had the axis of rotation been here, then it would have moved like this around the axis of rotation. But right now I'm taking this. For this derivation, see, when I'm taking a rod, mass is M. Yes, someone is asking? No? Okay. So suppose I am taking a small mass just for the calculation purpose. So length is dx and this is dm. Again, I'm telling you this is just to show you how we have to go through and how the formulas are actually stated, because the rest of these things you have to remember by yourself. Now I have chosen a very small portion which I'll be integrating. So if this is my axis, remember Harsh, I told you in the last class, take the axis as the origin. So this becomes 0. So if this is my axis, this becomes plus L by 2. So this becomes minus L by 2. This is clear? Axis origin plus minus. See, actual formula of this will become the dmx square from minus L by 2 to plus L by 2. Now mass of length L is M. So what will be the mass of unit length? It will be M by L. So what will be the mass of dx, this small length that we are talking? I want to find out this dm. Dm is the mass of dx. So what is mass of dx? If for unit length, 1 unit length, I have m by L. So for dx, it will become m by L dx. I just wanted to remove this. I just wanted to remove dm. I wanted to have x in my calculation so that I can integrate it from length minus L by 2 to plus L by 2. I can integrate it. That's why I did this. Otherwise, the formula was fine. Now what the formula will become? I is equal to m by L dx x square from minus L by 2 to plus L by 2. This is better to solve. This is easier to solve. Now I can solve this x square. How do we solve? X to the power 2 plus 1. This power comes in the denominator, right? And then the limits minus L by 2 to plus L by 2. What are the constants left in this process? M by L. So this becomes mx cube by L3. This is still from minus L by 2 to plus L by 2. Let us put in the limits now, right? We have solved everything. We have to just put in the limits. So this becomes m by 3L. Let me take it. Upper will come first. No? So that becomes L by 2 whole cube minus lower will come first. Minus L by 2 whole cube. So this is m by 3L. This becomes L cube by 8 minus into minus, that will become plus, plus into minus, minus, again minus into minus will become plus. So plus L cube by 8. Got it? See, this is minus L into minus L into minus L. So minus into minus is minus. Minus into minus is, minus into minus is plus. Then again plus into minus will become minus, and this minus will become plus. This is easy, though I'm just telling those who are getting confusion. So this becomes L cube plus L cube by 8. 2L cube by 8, right? So this becomes M 2 ml cube by 8 by 3 L 8, right? So L, the square will be cancelled. 2 and 4 will be cancelled. So you have your final answer. I is equal to ML square by 12. Please remember this class. Now class, one more important point that you have to remember. If I shift this axis here, the answer will not be the same. Okay class, answer will be different because then you will be integrating it from x equal to 0 to L by 2. All right, that we'll see. I think I will have it. I'll let you know. I'll let you know that. Okay. So different figures are present that you have to remember by yourself. Note down this. If time permits, then we'll do the other figures. Otherwise, that we'll do in the next class. Note this down.
Ma'am, can you explain how we got x squared there?
Yes.
Ma'am, can you explain that step m by l dx x squared, how we got that?
This step,
No, ma'am, the one above.
this step.
Yes, ma'am.
See, the formula I've told you, no, when we, this formula. So dmx square was already there, right? So instead of dm, what we have obtained? See, this was already present. Now we have obtained what is dm? Dm is the mass of dx. Like mass of length L is m. So mass of length dx is dm. So now using unitary method, we have calculated the value of dm. This is actually dm. Mass of dx is what? That is dm. So that's why I've just substituted it in place of dm. Got it?
Okay.
Okay, class, all those who have completed, you can leave. Next class, we'll continue this. Ali, I share the solutions with you on WhatsApp then. Time is already up. I'll try to share the solutions on WhatsApp.
Okay, ma'am.